Hello and welcome to this video on probability and relative frequency. So what is relative frequency? Well, relative frequency is probability based on an experiment rather than theory. So a lot of the probability you might come across on GCSE is based on theory. So for example, when you roll a dice, there's a 1/6 chance you might roll a 6. That's based on the theory that there are 6 equally likely outcomes on a dice. Now, relative frequency is slightly different because that's based on you actually rolling the dice. So you might roll it 100 times and count the number of times it lands on each number instead, and you would base the probability on that rather than just the theory. So the way that you calculate it is to take the number of times an event happens and divide it by the number of different outcomes. So for example, if you flip a coin 100 times and it lands on heads 60 times, the relative frequency would be 60 over 100. Could be simplified down to 3/5, or you could write it as a decimal, which is 0.6, or 60%. So you can write relative frequency in the same way you can with probability, as either a fraction, a decimal, or a percentage. There is a formula you can use for this. So relative frequency can be written like this. So the frequency of the event occurring divided by the total number of trials. So we saw that with the previous slide when we had 60 heads out of 100 trials. Let's have a look at a question for this then. So the probability that a biased dice will land on a 6 is 0.3. Now it's going to be rolled 200 times. So we're going to work out an estimate for the number of times the dice will land on 6. So all we need to do for this is just use 0.3 times 200. So now this is still partly based on theory, but you'll be given a specific number of times here, so 200 times. So sometimes they might ask you on relative frequency questions to use the relative frequency to complete another estimate. So they might give you data based on the dice being rolled 100 times. You've got to do it for 200, for example. So all you've got to do is take the decimal and multiply it by the number of times you intend to conduct the experiment. Very simple example on this next one. So the probability that Matt scores a penalty is 0.96. It's going to take 25. Let's work out an estimate for the number of times he will score. So all we've got to do on this one, same as before, take the decimal, multiply it by 25. Okay, so this table shows you the probability that a biased dice will land on each number, and it's going to be rolled 200 times. We want an estimate for the number of times the dice will land on 2 or 4. Okay, let's take a little look here then. So first of all, if you add up the probabilities we already know, so we already know 1, 2, 3, 5 and 6, we already know those. If you add those up, you get 0.76. Well, if you take that away from 1, that gives you 0.24. Remember, all probabilities, when they're in as decimals, add up to 1. So that's the probability that it's going to be a 4. If we add that to the 2, we get 0.44, so it's a 44% chance, essentially. Multiply that by 200, and that should tell us that we would expect it, based on this, to land on there 88 times. Okay, so now we've kind of used probability to sort of do some estimating with relative frequency. This time we're calculating relative frequency now. So Rosie's made some phone calls to try and sell broadband. She's done 120 of these. We've got a table here to show the results. And then I want the relative frequency that a call was not answered. And then second part, the rest of the week she's going to make 500 calls. So what would the probability be? What would she expect? How many sales would she expect to make during the rest of the week? So the first part of this question then, all we've got to do is look at the right part of the table here, so we can see that we've got not answered there on the top row of the table, just here, and we can see that's 33, and we know it's 120 calls because it tells us in the question, so we can write 33 over 120. If you want to simplify, you can simplify it to 11 over 40. You can write the decimal 0.275 if you do 11 divided by 40. If you want to turn it into a percentage by timesing that decimal by 100, you can also write 27.5%. Either one of those four things would be acceptable. Okay, second part then. Well, the sales were made on 6 calls, so that's 6 out of 120. If we multiply that by 500, it would be 25. So she would expect to make 25 calls during the rest of the week, based on those 120 calls that she made in the first week. Okay, so on this question, then there's a lot of data here. We've got a factory that makes kettles, and there have been 4 samples of these kettles tested for faults. Each sample has a sample size of 200, and we've got the relative frequencies based on those samples here. So these are the probabilities or relative frequencies that the kettle was faulty in each sample. So we want the range here, so think about what range means. The range of the number of faulty kettles in all 4 of those samples. Let's take a little look at this one then. So what we've got to do is, here we've got the probabilities here, or the relative frequencies. So we need to know actually how many kettles there are. So all we need to do is multiply those decimals by 200. So 0.03 times 200 is 6, so that's for sample size P. So essentially 3% of them were faulty. So that would be 6 kettles. For Q, 0.035 times 200 is 7, so 3.5% for that one. 0.015 times 200 is 3 for R, so essentially 1.5% of them were faulty. And then for S, it was 1% because we're doing 0.01 times 200. Now range, remember, is always highest take away smallest, so we've just got to take the highest number there, which is 7, so that was for sample size Q, and then we've got 2 for S. We take 2 away from 7, and 5 is going to be the range. Okay, and that is it for this video on relative frequency. So thank you very much for listening. Please hit subscribe if you want to see loads more content to help get you ready for the GCSE Maths Foundation syllabus. Thank you very much. Bye bye.